Hi, it's Andre again. Today we will talk about some design pattern or OO-oriented object pattern, which will help you a lot when you are creating a lot of classes. At some point, I call it there a Flyweight service facade. Okay, you probably use this in another project like IoC Container or something. We'll go around some what you try to solve with this. Okay, so the problem is you create a cohesive set of classes and you want to get one without having to worry about the dependencies or doing new everywhere. Okay? And you want having a single entry point. It's like the facade. We'll go over in a few moments. Okay, you have a like your model and you have a set of classes and you want to access the class F. But at some point you won't be able to access it because it's dependent on D. Then yes, it will be available, but you should access only on D, which in other words should only be accessible by B. And also you want to instantiate only at runtime. It's like a container, inversion of control, a container. Okay, we can go over like a solid principle, which is which is dependency inversion principle. Then sometimes you create a script and you put a lot of stuff in it and it's a script. It will work, but you can transform it into a cohesive set of classes that will solve the same problem. By doing this, you will inject dependencies and then you will have a more flexible model. It's what it states here. But by doing this, you create more classes and you need a pattern to access those classes because your colleague won't know how to create those dependencies, and it will just make new everywhere, and it will inject a mess into your model. Then, at that point, you can create a facade implementation. If we go over like a design pattern book, or today's we have Code Guru accessible on the web, we can look for some creational pattern, which is a facade. A facade is it provides a simplified interface to a library or a framework or any other complex set of classes. It's the problem I try to solve. You can also mix it with a structural design pattern, which is the flyweight. At some point, you won't need the classes, you won't need to do new until you really need to access to it. It's like a real container will work also, okay? And it will manage more complexity. But here we will just do like a basic example how we can do it. Okay. If you want to look for some other pattern, you can have some implementation for the Windsor container from the Castle project. It's an old one, not an old one, but it's like a 20 years old pattern. You can also have an inject or in .NET. You can also have in .NET Core, you have a singleton, you have service, and you can add singleton. It's already been built in the .NET Core. So that's fine. Let's go code. Let's see how we can do it. At some point, it's a basic implementation. If you have nothing and you just try to move from your monolith to a microservice or SOA, or you try to refactor some part of your code and you need to extract some behavior, this pattern can be really helpful. Thank you for watching. Let's go at the code now. Hi, so let's do it with some classes. Let's say we have one class. Let's say we call it class E, okay? That will need a logger, okay? Then we can just do it with a constructor saying that it will require a logger, okay? Then let's go with the class B, another class in our system that it's behind a complex set of classes that would need the class E, and at some point we can also inject the class the logger. Okay, then for that we will also need a logger. Let's do it. We can create my logger, okay, or we can use any kind of logger, it doesn't matter. We have a logger, that's it. Then we will have to instantiate the logger that will be injected in the class E, and then the class E will be injected in class A and then in class B. Okay, we can go by doing new everywhere, but if you want to do new on class B, you will have to provide the class A, and for having the class A, you will have to do provide the class MyLogger. But if you have a class C that need the class A again, you won't do new again. You can hide all this implementation behind a facade. Okay, we will go over with how we can implement a service facade. In some cases, you will see that if you use like an inject or container or a dependency inversion, any kind of tool you have, it's work like this. Okay, you just register your stuff, and it's when you request the classes that it will do new on every classes that it needs, and then it will bring you the class. At some point, it's like a singleton. Okay, don't go too deeper like this, but if you are interested in inversion of control or container, you can look about implementation, like I said. Keep watching. Let's continue with the implementation of the Flyweight service facade. Let's see, we need at first, we need the class, okay, Flyweight service facade. Okay, then for this we need an initialize. When we construct the class, we instantiate the class. We will need at some point a way to see that the class is contain an array of services, which is all the registration we'll put. We'll see in a few moments. And initialize is just a way to have it like a smart part. Okay, I call it my stuff smart. Is if you don't need it, don't instantiate what you don't need. Just instantiate what you need when you request them. Then if you have a big application and this service is called once a week, then okay, you just call it once a week. You don't pollute the memory with unusable stuff. Okay, this is just a way to do a good, sometimes good implementation. Then we will have a method called get in order to get our service from the facade. Okay, then like I said, we will have to call init, which is smart. Then if it's not initiated, then we will init it, and after that we will just request the service, and we will select inside the implementation into the array which service we want. For this we will use the class name, okay, because we will have like in C#, we can have a fully qualified class name. Then here is the same thing. We will have to look into our service for service definition, where the class name is equal to the class name which we want. Then here is the definition where we have the class name and how to construct or the instance. In that way we will use the instance already, and then we get the instance. Okay, another part that is cool, we can have reset. At some point it can be useful because you want to reset and restart from new instance, but if you have stateless services, it won't be useful, but it could be a nice thing to do. Then we have some private methods. Then it's the init part. Okay, like I said here, we have an init part. Okay, but we do in init. But if it's already initialized, we don't do anything. We just return. But we will have to create the logger, and here it's my logger. Okay, this one was the old Ruby one. It's logger. Then I have to register the logger. Like I said, it will use the class name. Then it will get the class name of this, and it will register the logger, and it will set initialized. Okay, it's at some point straightforward. We'll just do some like this, but I think my indentation is bad. Okay, and then what we want to do is to have a method to register what we want. Okay, here it's a private one, but we can use the facade in a way like the container is done by exposing, make this register public. Okay, it's another way. It's your implementation. You are free to do what you want. It is just a way that we will put all our dependencies and implementation inside the factory. But you can use another way, inject it also. This is, it remains on you. Okay. Then at some point, if you look at this, it's like a builder, because it will know how to build our stuff, how to build to make our dependency. And when we will ask this service for a particular class name, it knows how it has been constructed with all the dependency, and we do a new once. We aren't doing new everywhere, always redoing the same stuff and having a lot of stuff in the garbage collector. Yes, we have a garbage collector, but we can also do some stuff to make it simple. Okay, then here I just registered my logger, but like I said, I have a class E. Okay, that's fine. Then the class E, if you remember, need the logger. We can go back here, the class E need the logger. Then I create a class E that need my logger, I inject it. Okay, but I have to register the class E. Okay, let's put it just here. Okay, the class E, the class A. Then when I will need the class A, it will be already instantiated, and I will just have to. But remember, you need to, for that you need to have a stateless class. If you have to use stateless state class, you will need to construct a new one each time. It's another kind of design. If you go like this, you will probably need a factory that will create a class with, you will inject inside some state, and the class will be like a command. Okay, but this is another kind of trick. Just think about ETL. Okay, sometimes it's a way of programming. You extract data, you transform it, and you display it to the customer. Okay? It's always the same thing. You have data in your database, you extract them, you apply some transformation, and then you display them to the customer. Okay, ETL. It's always like this. So let's continue with my class B. You remember the class B need to have the class A injected. Okay, I just create here. Then, like I said, you see here, it's the implementation like a builder. They know if you want to have the class B, they know that they have to create the class A, they know that they have to create the logger. At some point, it's like the facade. The facade is it's the frontier. Yes, a frontier that is, it hides the complex implementation, the complex set of class that you have done to resolve a problem, in order to make it easier from the client that use it. And don't forget to register it. Okay, that's fine. You register the class B. That's fine. So let's go here at the end, and we want to try it. We create the service facade, okay, and then we want to try, can we get the service A? Okay, let's go ahead and try. Okay. So, like I said, let's try if it works. We want to get the class E service. I just forgot to put the class.name here correctly, because it's this implementation of Ruby. Then when we run it, it resolves the class A, which has a MyLogger inside. Can we do the same thing with class B? Sure. We have a class B, which asks for class B, and then we can just get rid of class A because it works. Then run. Then we have the class B that has a class A, then the class A has my logger, and that's it. This is a way of that you can implement some kind of service facade in your code. At some point, yes, script is a way of programming, but if you do oriented object, you can do classes for resolving a complex problem. But you will face out a problem that you will have a lot of classes. How you can get rid of how you build that set of classes? The facade. The facade, it hides the implementation and it gives you an access point, an entry point to the other side. Okay. Then with the facade, you see here that I have a lot of class. Then if I want the class E or the class B, it's easy. You just ask the facade and it will instantiate it for you. A real container, it's much more complex, just like this. But this is like something you can build on your day-to-day project, and it's easy to put in place, and you will save a lot of time. Then what you have to offer to your client, it's if you want to call my implementation of my context, you have to come to ask my facade that will give you the class that you will need, and you will at some point expose your it's like if you have a DLL or a gem and you just expose public method. Okay, usually if you look inside it, you just have to do new, and all the dependencies it's built inside. It's the same thing here. So thank you for watching. This is a way of doing a facade, and you can implement it and use it tomorrow if you want. It's on your own.